Along with the map and the video window, central to this InnUVative Systems Force Control Station is a System Status Panel. This is effectively a warning panel, though it also shows green statuses, which are simply informative, not just alerts and cautions. And it is divided up into several different tabs. The primary tab is the Monitor tab. This allows the operator to have one single place defined for them to look and see whatever is going wrong with the systems that they are controlling. However, the other tabs allow them to also examine the various alerts and informations and cautions that are up there by either priority or by system. In this way, they can take a look at all of the alerts generated by, say, the ground system, or by any sensors, or by vehicles, even when they are flying multiple vehicles with multiple ground systems, potentially with multiple payloads. The Monitor tab is the first place where all warnings come. All status information is placed on the Monitor tab first, and when a new warning comes in, the Monitor tab is automatically pulled to the front so that the operator can see exactly what has occurred. There are several different types of warnings. Here you can see 2 red warnings and 2 flashing red warnings. In actual fact, the flashing red are not only just flashing, they are also audible. As can be demonstrated, if I move this particular warning off, I can actually move it back on and you'll hear the audible warning. This draws the attention of the operator that a warning has been placed onto the Monitor tab and needs to have his recognition. The warnings themselves have text which describe what the warning is, icons which describe what system is affected, some text which also describes the system that is doing the reporting, and several icons that are control icons here. The one on the far left, this is a STANAG 4586 warning that has the ability for the operator to clear the warning. What this means is that if the operator hits this icon, a message is sent to the vehicle-specific module saying, "I acknowledge this warning. Please stop reporting it unless it goes out of the bad state into the good state, and then back into the bad state." In this case, I can clear it. It will, however, come directly back again because this warning keeps getting regenerated. So we see it come back again. On the other side, you'll see some InnUVative specific icons that can be used by the operator to manage his warnings and make them more effective for his mission at hand. For instance, if I know this unknown warning condition is sporadic or spurious and not really of concern, I can use this icon here to do what we call parking the warning. It's now removed from my Monitor tab. However, it's still present in my Alerts tab. It's also still present in my Ground Systems tab because it is a ground system alert that's being generated. Likewise, if I know for whatever reason I'm flying without a GPS, I may not wish to have the GPS warning on my Monitor tab distracting me from the genuine warnings which may occur during my mission. And I can do likewise with a magnetic field warning. Again, all of these are on the tabs that are associated with either their priority or their system. They can also be moved back, as was seen previously. I can hit this, it'll go back onto the Monitor tab, and if for some reason I wish to place it back in my most heavily viewed tab. However, if perhaps I want to look at the alerts, for instance, separate from my warning tab or my Monitor tab, I can actually pull the tab down and actually set up a separate display. This allows the operator to do some customizing of his warning and alerts display without actually losing the ability to have a single place to look for all of his warnings and alerts. Likewise, I can even pull down my ground systems and be monitoring that separately as well. This kind of configuration gives the operator the ability to set up the warnings and displays in a manner that is most efficient, not only for his system and his particular mission, but also for himself personally, if he determines that he has a preferred way of working. The last thing you'll see is in this is this last icon here. What this is it's a wizard. So when a warning is generated, certain warnings within a given system typically have corrective actions that are predefined. In order to make sure that the operator reaches, gets the corrective actions correct, and is able to find the correct dialogues for the correct vehicle, because there may be multiple vehicles that he's controlling, the wizard actually opens up the dialogue along with the text. This text is defined in an XML file that is able to be modified by the end user. So if they find that they want to change the corrective action, they don't need to come back to InnUVative Systems to change this. In this instance, I know that this low altitude issue is a result of not having yet launched, so I will follow the instructions that are laid out for me here, put it into waypoint mode. You see that we've actually got a green status information coming up indicating that a nav information status has been sent to us by the vehicle. We launch it. We'll see the altitude start to increase. As the altitude increases, we'll go back to waypoint mode. We'll set the altitude at a reasonable altitude, and then we can actually close this dialog. If, however, there were some more corrective action that needed to be taken on a next dialog, instead of a close button, this would be a next, and it would open the next dialog required along with the text that is associated with that dialog. And in this way, the operator has an immediate an immediate ability to be self-guided through the corrective action. Where it's possible to automate the corrective action, that is of course a faster way of implementing the corrective action. However, in many cases, the operator still is desired to be in the loop. Therefore, this way makes it not quite automated, but still very quick, very effective, and easily executed even under stress. Finally, the last thing we'll notice here is that whenever I go in and I change my altitude down to something low, I'm going to bring back the altitude warning that we saw earlier. I want to see the vehicle actually come down and drop below 12 meters. We'll see the red warning come back and indicate that it'll actually be in a solid red state because the flashing red is reached at 8 meters. However, as it drops down below 12, I'll actually bring it back up above 12 again so that the warning gets cleared very quickly. And what you'll see is that the warning doesn't actually disappear, but instead turns gray. And what that does is it gives the operator a minimum amount of time to actually read the warning so that he doesn't have a red warning flipping in and out that he can't read. But as you saw, the warning actually turns gray and gives him that minimum amount of